Hey friends, welcome to Coach for AI. My name is Sharnan the Coach, and we are in the second video of this 5-part series where we are discussing about machine learning algorithms that are necessary before jumping into more complicated stuff like deep learning. So in the previous video, we had discussed about a KNN classifier, and now we are looking into a clustering technique which is called the KMeans clustering. Now, in clustering, what we do is we simply group samples. Like for example, we have two samples, but we don't know what these samples actually represent. So we have two different kind of animals, and we are basically measuring the length of the animal and the weight of the animal, and we have expressed them in the form of a scatter plot. Now we actually don't know which of these data point belongs to which class. All we have is just the values of the length and the weight of the animal in question. But what we can see from the scatter plot is that it forms two distinct groups. Now for more complicated problems, this might not be so easy to look into, especially for higher dimensional problems. In those cases, we use something called a clustering algorithm. Now one of the simplest clustering algorithm is called K-means clustering algorithm. Here we kind of divide the sample space into k different number of clusters, and for representing every cluster, what we do is we take a mean value which represents the centroid of the cluster. So for k different cluster, we have k different mean values. Now to start with the algorithm, what we have to do is we have to randomly initialize 2 points which will act as our means for the clusters. So if our goal is to divide the space into 2 clusters, then we need 2 means. So let us randomly assign 2 mean points which will ultimately try to find the centroid of a cluster. Now we can consider them with an analogy, like for example, let this red and green yellow dot, they represent 2 captains of 2 different teams, and these blue squares and green circles are players who are going to play the game. Now each of these captains' duty is to select that group of players which are nearby. Now what they are going to do is they are going to stand at 2 different random points, and each of them will say, okay, the player who is nearest to me belongs to me. So if both of the captains say the same thing, that the players who are nearest to me belongs to me, then what they're doing is they're kind of drawing an imaginary separation line in the sample space which divides the groups of players into 2 parts. Now, so the yellow captain will have say 2 samples from this blue cluster and say around 7 samples from this green cluster, and the red captain will also have something similar. Now, what these captains will do is they will say like, okay, fine, we have selected a few players, now let's go in the middle of these players. Now the captain is very far away from the players or the samples, so they are kind of going to move to the center of the players that belongs to them. Now if the captains move to the center point of the players that belongs to them, then what will happen is some of the players will notice, okay, this captain or this mean point was somewhere else when the game started. Now they have changed their position. Previously, one of the guys may say, okay, previously I was much closer to the red captain, but after they have moved, I am much closer to the the yellow captain, and they might change their decision as to which of the captain they belong to. So what will happen is this pink hyperplane, that this thing is going to shift, and there will be some reassignments of players, and some some players will change their sides. So what will happen is if the hyperplane is again shifts in a way that it's in the middle of the 2 captains, then it looks something like this, and you can obviously see that some of these samples, say for example, say these sample in question, say this green sample, it belonged to the red cluster, but now after shifting it belongs to the yellow one. And again the captain will say, okay, since the hyperplane has shifted, since the separating boundary has shifted, I need to move again to the center of the players that belong to me or the samples that belong to the group, and again they will kind of move to in that direction. and this will continue, keep on continuing. They will move, change their position, they will go to the center of the samples that belongs to them, and again some of the samples will get reassigned because the captains have moved or the mean position have moved. Now they are nearer to a different mean position, so again the hyperplane will shift to a direction which is in the middle of the two captains, and again some of these samples have changed, switch sides, and again this process continues. Because there has been some reassignment, the means have to move again to the centroid of the samples that belongs to them, and after moving we will see that again there is another chance of reassignment, but in this time we see that the hyperplane has shifted a bit, but there has been no switching sides anymore. So we can say that all the players are very satisfied with the captain that they belong to, and nobody wants to change any sides. And if nobody wants to change any sides, then the mean positions also do not have to shift anymore. That is, the captains do not need to move anymore. They are already in the middle of the players or the samples, and hence this is where the algorithm ends. Now you can see, while doing this algorithm, it did not matter which classes this represent. The mean position, they started from random points, and all this saw was which of the samples was nearer to them in terms of the feature values or the values in the x or y axes in which these are like plotted. And this is how clustering works. It looks at the data distribution and it kinds of tries to find a way to get the centroids and kind of create a hyperplane between the two clusters. And K-means algorithm is a very beautiful algorithm, as you can see, that just starts with these random positions, and these mean points, they keep on moving to the centroid of the samples that they belong to, and until like they get a saturated point where there is no more switching sides, and that's all that happens, and we have got a very simple algorithm that can do a clustering. Now this K-means algorithm was again invented a long time back, but it has survived throughout many decades, and just because again of the simplicity and its efficiency for data spaces, and many new modifications have been proposed over this K-means algorithm. One of the most important modification that I believe exists is something called the fuzzy Siemens clustering. Now the fuzzy Siemens, what it does is, so when we were drawing this hyperplane, if you remember, all these captains were choosing which of the players are nearer to them. So if we have a sample and so if we have this blue square and just because it is little bit nearer to the yellow sample, it belongs to the yellow sample, and because it's farther from the red sample, again it cannot go to that side. But in fuzzy Siemens, what it does is, instead of giving a kind of full right, say the captain will not have full right over the player, rather the membership of this player to a specific team will be in the ratio of the distances from the captains. Like, so if this distance from say the yellow point and the red point is in the ratio of 6:4, then the membership of the sample to both the classes is also in the ratio of 6:4. Previously in normal K-means, what it was been done was, the membership was either 1 or 0. That is, it either belongs to one class or it does not belongs to one class. But in fuzzy Siemens, it's more probabilistic in nature, and the players were kind of say like, okay, 60% chances that I will be belonging to this captain, or 40% chances I will be belonging to the other captain. And the probabilistic method or the fuzzy Siemens method has also proved to be very efficient in many problems where it deals with uncertain situations in a very good way. And it's also one of the basic algorithms when it comes to fuzzy logic based approaches. I would please request you to read more papers on these kind of techniques, so like K-means and fuzzy Siemens and so on. And here I have provided some references again from where you can read them. So there is the Wikipedia page which has the K-means cluster, and we have some blogs as well. So the APIs is again from scikit-learn and MATLAB and Weka. And again, I will especially point to Weka 3. It's a very easy software in which we can do a lot of machine learning algorithms. And this one of the best book in the business is the one by Bishop. And also these are some of the papers that have been built upon the basic K-means algorithm. There are some efficient versions of K-means where you pre-calculate the distances between the points. We also have a much more intelligent initialization of the points, or we can basically go for the fuzzy versions as well. I would also like to grab your attention towards this demo where we have a very nice visualization of the K-means algorithm. Okay, so this is the K-means algorithm visualization. So we have this nice clusters, and we have three mean points for these three clusters. And what we are going to do is we are going to we are going to do this iteration, and we are going to see how these samples move. So first what we are going to find the closest centroid. Like all of these samples, they will be assigned to the closest centroid. And okay, so we have done a reassignment of the samples to the closest centroid, and you can see that they have formed like a blue, orange and a green cluster. And now we have to move the centroids to the center of the samples that belong to them. And if we move, we see that there has been a movement there's a movement in the mean points, and again we find the closest centroid, that is we do the reassignment of the samples. So we see some of the samples have changed their sides, and then again we update the samples. There is again movement. We keep on finding the closest centroid and we update. We keep on updating, and finally you see that the samples have moved to the almost to the center of the distributions. And if I keep on updating, you'll see that there is no more movement. That is, there are no more refinements or switching of sides. And we can also check with different kinds of distributions. We can increase the randomness, we can increase the number of clusters that we have, we can increase the number of samples that we have. So let's see. But the thing is, K-means algorithm is dependent on how it is initialized. Now if we see in this case, if we keep on updating, okay, so here also it works fantastically. Let's have new centroids and we keep on doing that. Okay, so in this case you can see that this orange mean is actually capturing these two two clusters together, and this purple point is not near any cluster. So this can sometimes happen because of bad initialization scheme. This K-means algorithm might not give you satisfactory results. So it's very much dependent on how you initialize. There have been some work in much more smarter initialization techniques, and that's that. So if we have new centroids, if we keep on doing this, yeah, now it's the case with this purple mean point. It's actually grabbing two clusters together. So see, when you have a large number of clusters, this can be a very big problem in K-means, but it still works in many cases, especially in cases where these clusters are well separated and the number of classes is also not too much. But in other cases we can also go for fuzzy based methods, or even we can employ the techniques of something called cluster validity index, that is, which says how good a cluster is. That is also something to work on. So with all that, I bid you farewell and have a very good day. Okay, so I'll be giving a link to the presentation that I'm using in the description below. If you liked the video, give me a like, or if you didn't like, give me a thumbs down and tell me how I can improve this video. And also tell me about what kind of things you expect from me. Or if you have any questions, ask me in the comments below. I will try my best to answer them to the best of my knowledge. And subscribe for getting more updates in the future. And don't forget to click the bell icon for notifications. See you and have a very good day. And thank you for watching.